Hi, Nicole. This is for problem 6.6. And in problem 6.6, they ask us to take this radial part of some equation and show that a given function R, and show that a given function, this function, is a solution. Now, to show that this is a solution, all that is necessary is to substitute this in for all of the r's there, the big R's, and get rid of everything that is that contains a little r, because the energy for a real quantum system is a constant. So you should not have any variable in it. So this z is a constant, this e is the charge of the electron, that's constant, this epsilon naught is constant, the L is the quantum number, that's a constant. All these are constants except for the little r. So in other words, to show that this is a solution, we put it in and get rid of the little r. Just do all kinds of algebraic gymnastics until the little r is gone. If you cannot do that, then that means this is not a solution. If you can do that, then yeah, this is a solution, no matter what it is, and you have just found the energy for this quantum thing in this equation, this situation. So this is the thing, and this is the situation. This equation is the situation. Okay. So I'm going to do this in a couple of videos because my video recording software chokes if I make the video too long, and this is going to take a long time. The reason this takes a long time is only because of algebra. There is no science concept here, just math. Okay. Now let's see. The algebra is quite involved, so I'm going to do this in several steps. Now, there is a big derivative thing here, right? So I'm going to need the dr, the first derivative, and this is a dr of all this, so I'm going to need the second derivative also. And the dr of all of this is going to require the product rule, so this is really a function of the first one. This is my product rule here. Function of the first one times derivative of the second one plus function of the second one. This is the second one, the second function, times derivative of the first one. Derivative of r squared is 2r. All right. That goes in for this DDR thing. Huh, DDR. Dance Revolution. Oh, you might be too young for that, right? So now I'm going to get I'm going to use this space here to find the derivative of this, and then the second derivative of this, right? So the dr is, now this is another product rule. So I've got function of the first one and the second one, right? So n, which is a constant, times function of the first one times derivative of the second one. Derivative of an exponential is the exponential itself, and then you commit chain rule on it. Chain rule. I commit chain rule. Okay, that looked like an exponent. Okay, that's chain rule. Plus function of the second one times derivative of the first one. Derivative of r with respect to r is just 1. Okay, now I'm going to factor out this guy. I'm going to factor out Pinky. Mr. Pinky here is getting factored out. Okay? So this is now n e to the minus r over 2a naught. This thing with factoring, factoring is really just dividing by stuff and putting it in the front. So I put this pink stuff in the front, and there it is now. And I divide it out of here, so this divided by the pink stuff is this. This divided by the pink stuff is just 1, right? It's important to remember that factoring is a process of division on the inside and then multiplication on the outside, right? Now I'm going to take this. This is the derivative, and the derivative goes in there, of course. I'm going to find now the second derivative for that part, right? So the second derivative, I'm going to need more room. Second derivative. So that's going to be it for this video. I'm going to find these two derivatives, and then I'm going to continue in a new video. All right. So now the second derivative. So this n is a constant multiplied by everything, and then I have two functions here. Function of the first one, function second one. Right. So function of the first one is this guy times derivative of this stuff. Derivative of this stuff is just the coefficient here, negative 1 over 2a naught. Right. So that's negative 1 over 2a naught plus function of the second one, so this is the second function, times derivative of the first one. So derivative of an exponential is the exponential. And then you commit the chain rule. I commit chain rule here. Okay. Right now I'm going to simplify this a little bit. In these videos, which are all for problem 6.6, I do a lot of simplification, and not all of it is necessary. I do it because it's easier for me to look at stuff without getting confused when there's less stuff to look at. So I do it to compact things. It's not necessary to solve the problem. So there are some steps here that you could skip, or there are some steps here you could do very differently. There are many different ways to approach the work here. So I'm going to factor this guy out. So there is a term here plus a term here. I'm going to factor that guy out of those two terms. So remember, factoring is just a matter of multiplication on the outside and then division on the inside. So on the inside, I divide that out, and I end up with this. Okay? Now it looks like I can do some more simplification, so I will. I can simplify this to, I can distribute this out, all right, and then see what I get. Very often, the math that they make you do in a quantum class is just a matter of trying different things until you could find something that works for you, you know? I have tried several different things in advance, so you don't have to see all the trial and error that occurred here, but a lot of trial and error was done here, and that's what you have to do when you're trying to figure out a new problem that is heavy in math. You just gotta try some ideas, and if it doesn't look right, don't throw it away. Set it aside and try some other ideas, and you just keep on trying until something looks right to you. And doesn't break any math laws, of course. All right, so now I have a negative 1 over 2a naught and negative 1 over 2a naught. So I'm going to combine those. Do you have to combine those? No. No. I just do it because I don't want to be confused. Oh, so this is going to be two of them. So negative 1 over 2a naught minus negative 1 over 2a naught is negative 2 over 2a naught, which is just negative 1 over a naught. Right? Right? Yes, yes. That's half, so you get it whole. 1 over a naught. Okay. I think there's something I'm missing here. The second derivative, is this what I had for the second derivative in my notes? Actually, this looks a little different, but is that going to be okay? No, this is the same. Okay, this is good. All right, so yeah. You can keep it like that. That is okay. Or you can do some more factoring, right? So I prefer to do some more factoring. So that's what I'm going to do, but you don't have to. So I'm going to factor out a 1 over 4a naught squared. It's some kind of a weird thing. I don't think other people would do that, but I want to do it. So factoring it out means dividing this. So if you divide this by 4a naught squared, if you divide this by 1 over, if you divide this by 1 over 4a naught squared, then the 4a naught squared disappears from the bottom there. And if you divide this by 1 over 4a naught squared, so 1 over a divided by 1 over 4a naught squared is multiplication by the reciprocal. There's multiplication of fractions, and then this gives you 4a naught. All right, so this is going to be 4a naught. Wait, I think I am missing something here. Am I missing something here? No, I'm not missing anything. Okay, so this is good. This is good. All right, so this is what I've got for the second derivative. Right now, remember, the second derivative in baby blue here, the second derivative is going to go into this part. And in red, the first derivative right here, this is the first derivative. This whole, no, not that. This whole thing is the first derivative. This first derivative is going to go in there. Okay, first derivative. Right, and I will substitute those in the next video. Thank you.